Welcome back. According to our earlier presentation, there is a transaction management. In the transaction management, one of the important aspect is concurrent execution. What exactly here? Concurrent execution. There are more than one transaction is going to be executed simultaneously. So concurrency indicated here execution of more than one transaction simultaneously. It indicates like multiple transactions are allowed to run concurrently in the system. So if you can do like this, what is the advantage? So basically increase the processor and disk utilization. So it leads the better transaction throughput. Here particularly we would like to mention one important keyword is throughput. It indicates number of transactions performed in a unit time, indicate throughput. So concurrently executed number of transactions, it leads to increase its throughput. One transaction can be using the CPU while another is reading from or writing to the disk. So another advantage with this concurrent execution is reduced average response time for a transaction. So it means the short transactions need not wait beyond long ones. So because of these two reasons, we normally prefer to execute transactions concurrently. If you can do like that, it means that concurrency, the transactions are going to be executed concurrently. We need to manage one mechanism to control this entire thing. Otherwise it leads to some inconsistency or other kind of issues will come into a picture. To achieve this mechanism, concurrency control schemes through the isolation. This is to control the interaction among the concurrent transactions in order to prevent them from destroying the consistency of the database. So basic aim of that database is to maintain its consistency. But whenever it is going to be executed concurrently, it's need to be performing some type of control mechanisms. So in this first, we need to look at make transactions into schedules. So that is the one of the important point here we would like to mention, schedules. It is a schedule. What exactly schedule? It is a sequence of instructions that specify the chronological order in which instructions of the concurrent transactions are executed. There are more number of transactions are going to be executed in a chronological order, the order which you have to be mentioned. A schedule for a set of transactions must consist of all instructions of those transactions. So according to this scheduling must preserve the order in which the instructions appear in each individual transaction. The order of the execution of transaction most of the time is very important aspect. So a transaction that successfully completes its execution will have a commit instruction as the last statement. By default, transaction assumed to be executed commit instructions as its last step. So once it leads to the commit, it indicated that your entire transaction performed properly. A transaction that fails to successfully complete its execution will have an abort state. The instruction has the last statement. So then here important aspect abort. In the earlier slide, in the earlier presentation, we discussed there are 5 states. One among abort is one state where the transaction aborted because it has not happening properly. So let us see how the scheduling is happening or planning in this. Let us use the same example in the earlier presentation. There is a transaction T1 and T2 here in this case. Let's T1 performs transfer $50 from A to B, and transaction T2 transfer 10% of the balance from A to B. Look at this schedule. An example, serially the transaction 1 and 2 executed. Look at here, transaction T1 executes first. In this transaction T1, transfer $50 deducted from A, write A, and added this $50 to B account, and at the end commit. Transaction 1 completed, then transaction 2 started. So when transaction 2 starts, according to the transaction, 10% of amount from the A account will be stored into the temporary variable and deducted from this temporary variable from the account A and save it. And now this 10% amount will be added to the B account. The serially the transaction as executed. It indicates serial means one after another. T1 is completed, then T2 enters. Look at another schedule here, a serial schedule in which T2 is followed by T1. First look at transaction T2 executed, then followed by T1. See here in this case, the final value has been transferred from transaction, from the account A to B has been bit changed. Here in this case, look at 10% initially after deducting, according to the earlier schedule 1, deducted $50 from the account A, then after find the 10%. But transaction 2 executes first. Here in this case, first 10% is stored in the temporary variable and subtracted from the account A, and B added this temporary variable 10% into B account. This result and schedule 1 results might be different. Values can be transferred from account A to B once the serial scheduling has been changed. So look at the results of schedule 1, look at the result of schedule 2 might be different. Look at into the schedule 3. In this, T1 and T2 transactions defined previously, the schedule is not in a serial schedule, but it is equivalent to schedule 1. But happening, look at here, in the transaction T1, first three instructions executed, then come to the T2, and first 3-4 instructions executed T2 and switch over to the T1. So here the transaction T1 and T2 executing simultaneously, but switch over the execution from T1 to T2 here in this case. So now once it's completed, the transaction T1, T2 execute simultaneously, but it preserves once the final value of A and B should be preserved its actual values. If it preserves, then it's maintained its consistency. Look at schedule 4 here. In this case, the concurrent schedule does not preserve the sum of A plus B, because here this transaction read A and subtract 50 rupees or $50 from A and then switch over from T2. If this transaction trace it properly, it leads to, at the end of this T1, T2, it does not maintain its final value added A plus B. It does not equals to the value. So to resolve these kind of issues, how to make this concurrent execution, it depends upon the serializability. This serializability, there are two types, conflict serializability and view serializability. It is trying to make your transactions performing concurrently. So it's make your data properly to execute. Thank you in this this presentation, and rest of the things will be coming to the next presentation. Thank you.